All right, so we still think about our a f of b x minus c plus d when we look at tan graphs. I see an a value of 2, which means a vertical stretch of 2. I see a d value of -1, which means a vertical shift. So I'm going down 1. That's where I'm thinking about my center line being. So I still, even for tan graphs, like to put in a center line. And now, the points that I know for sure on tan is that when I have 45 degrees, that's when the value is normally 1. So if I'm stretching this, I'm doubling all of my y values. At 45 degrees, instead of having 1, I would have 2. This was just over a half, so it's going to become just over 1. So that's what I'm thinking about with my tan graph. But my center values, so my zeros, those are where I see the D happening. This has no change of period. So since my B value is 1, this means my period is still pi. And we haven't horizontally shifted it yet. So I'm going to go in and put in my asymptotes. And this time I'm going to let every line be 45 degrees. So if we call this, we don't know how we're counting since x is not labeled as degrees, we're going to assume radians. So I'm going to call this pi over 4, and that means this is going to be pi over 2. So I'm going to put in my asymptotes. So pi over 2, and then negative pi over 2, pi over 3 pi over 2, and then negative 3 pi over 2. So negative pi over 2, pi over 2 here. So we know that in the middle of our asymptotes, that's where our center points are going to be. Our graph has been shifted down 1, so we can hit -1 for those. And now with my vertical stretch of 2, when I have pi over 4, normally I'd be at 1, but I'm doubling that distance, so 2 and -2. So graphing these 3 points, sorry, not -2, normally that space is down 1, but I'm doubling it to be down 2, and then up 2. So for tan graphs, plotting 3 points is enough for us to see what is happening. And again, if I want to be sure, I could pick a random point to test. So try to make smooth curves again. Okay, so let's pick a random point to test. I'm going to test this point. So 1, 2, 3, 4. This is going to be 5 pi over 4. So testing this, y is going to be equal to 2 tan 5 pi over 4 minus 1. Well, 5 pi over 4, sorry, this is not 5 pi over 4, this is negative 5 pi over 4. Negative 5 pi over 4. All right, so negative 5 pi over 4 is a full pi and then up to here. So coming this way, I know that in quadrant 2, tan is negative, so this is going to have a value of -1. So 2 times -1 minus 1 is -3, and that matches with our y value of -3, letting me think that my graph is correct. And of course, I could also graph it on my calculator if I wanted to see this as well.